Okay, YouTube, in this series of videos, we're going to be exploring solving radical equations. And so I sort of want to start with what we mean by a radical equation. One of them is given here. I'm going to rewrite this here. We say 2 times the square root of x plus 1 equals 4. And I only rewrote this so we could read a little bit better. But we say, I guess, equations with radicals that have variables in their radicands. We refer to these as what we mean by radical equations. So whenever you have a radical, I don't care what kind of root it is, but if you're taking the root of a variable and it's an equation, then all of a sudden you have a radical equation. So that being said, essentially these are pretty straightforward to solve. We've got a three-step process that tends to work pretty well. But let's go and take a look at those, and we'll talk about how it applies to this situation here. So it says to solve a radical equation, let's follow these steps. So step one, isolate the radical on one side of the equation if necessary. So in other words, up here we can see that the radical quantity is just this thing that has a radical over it. So indicating that, we would say that this 2 has nothing to do with that radical. So what we're going to do is we're going to divide both sides of this equation by 2. And I guess the idea is we need to isolate the radical. So what we get here is the square root of x plus 1, and this would be equal to 2. So step 2, now that we've isolated the radical, step 2 is raise each side of the equation to the same exponent to eliminate the radical and to obtain a different type of an equation. They give an example here. They give a linear, quadratic, or other type of polynomial equation. But the idea is, once you get rid of this radical, you're going to be left with x plus 1, which is just, a polynomial equation, which we really, really are good at factoring and solving those. So let's go and take a look at what we have here. Now, raising each side of the equation to the same exponent, that's really, really wordy. What we're going to do is we're going to give this a name. Okay? When you raise both sides of an equation to an exponent, we're going to call this exponent, okay, right? Exponentiate. So we're going to exponentiate both sides. And I guess the idea here is this. If you consider the fact that these two things, the square root of x plus 1 and 2, are identical, they're the same thing, then it's fair to say that if I were to raise both sides to the same power here, then I would have equality still. So this is still equal, and what I've done here is I've exponentiated both sides to the power of 2. And the idea behind this is, well, of course, if you take a square root and you square it, those are inverse actions. So I just get left with my radicand expression here, x plus 1. And on the right side, of course, you get 4. So if we were to subtract 1 now, look at this. Step 3 says solve the equation. Oh, sorry. Step 2 says now solve it like you normally would here. If we were to look at this here and say solve this, this is really just a polynomial equation where we get 3 for an answer. Now, the third step says solve the resulting equation using techniques you've learned in previous chapters and checking your solution. I guess what I want to point out here about the third step is that you check your solution always. So one thing that I'm going to encourage us to do in this video is, as we look at the solutions to our radical equations, that we plug them back in and make sure that they are actually valid. So checking this one out, we get 2 times the square root of 3 plus 1, which is the square root of 4. And of course, 2 times the square root of 4 is 2 times 2, and we get 4. So this certainly works, and it is valid. So let's go ahead and take a look at 3 other radical equations here. The first example of which is going to give us a cube root. So it says solve the equation, of course, check your solution. So example number 1, we have the cube root. The cube root of x minus 9 equaling 6. The idea is that we're going to need to get this by itself first. So let's get rid of this 9. We're going to add 9 to both sides. So we get the cube root of x is equaling, this was close, negative 6 here. So negative 6 plus a positive 9, if I were to add 9 to both sides here. Then I would get a positive 3 on the right side. So now that we've isolated this radical, what we're going to do is exponentiate both sides. And in order to get rid of the cube root, we'll cube both sides. So certainly if you cube a cube root, you get just the argument inside the radicand. You get x in this case. And in this case, we get 3 to the third power is equal to 27. So since this is our proposed solution, I'm going to put a question mark next to that. We need to check it out. So we get the cube root of x. This was taking 9 away from it and getting negative 6. And so we're claiming that this is a 27. And I certainly know that the cube root of 27 is 3, and 3 minus 9 is equal to negative 6. But this one works out. It is not always true that radical equations get solutions that are all true. So we got to check them. So let's take a look at number 2 here. Now, one thing I do want to say about this is this is not equal to the square root of x plus the square root of 25. Remember that I can only split up the radical if this is multiply or divide. So with what we have here, we really have the square root of x plus 25 by itself on the left-hand side. So what I'm going to do is I'm going to square both sides. We have x plus 25 inside the radicand here, and we get 2 here. I'm going to go ahead and square both sides to get rid of the square root. So we get left with x plus 25 on the left side. The right side, of course, 2 squared is 4. And if we subtract 25 from both sides, we get 4 minus 25 on the right. And x is equaling a negative 21. So I'm curious if this is actually true. Let's check this out. We get a square root of x plus 25 equaling 2, and if we put in a negative 21 here, the thing here you see happening is that this becomes a 4. And so we get plus or minus 2, but I'm going to say we get 2 is 2, and this would certainly be valid. So now looking at this last example, we have 2 times the cube root, and we have an x minus 3 on the inside, and our radicand, so 4. So the first thing, of course, we want to do is isolate the radical. So we're going to get rid of this 2 by dividing both sides by 2. So we're left with, on the left-hand side, the cube root of x minus 3. On the right-hand side, of course, 4 halves is 2. So let's go ahead and exponentiate both sides, this time to the power of 3. So we get x minus 3 on the left. On the right side, 2 cubed is 8. And if we were to add 3 to our 8, we would definitely get 11. And just checking this out here, if we were to plug in 11 back into this, we get 2 times the cube root of 11 minus 3 is 4. Now 11 minus 3 is 8. So really we get 2 times the cube root of 8 equaling 4. And the cube root of 8 is 2. So we get 2 times 2 is 4. And so this is valid and all of these solutions work. So the idea is to isolate the radical, exponentiate both sides where appropriate, and then we'll solve knowing how we know how to solve. So cheers.